Welcome to DriverDTrains. Thanks for stopping by. I'm your host, DriverD. Our conductor and brakeman, Scratchy-C, has gone out to do some holiday shopping. In my last video, I introduced you to EX-Rail, the automation component that is included within the DCC-EX EX-CommandStation software, described some of the things that EX-Rail can do, and provided a basic overview for how we can use EX-Rail to plan and create our own automations. If you haven't already seen that video, be sure to check it out. In this video, part 2 in the series, we'll go step by step together through the process of creating a set of automations to run one of our trains. The example we will use is the automation that drives the train off the layout each time I complete an operating session on the D-Saver. We will create 4 slightly different versions of this automation to use depending on how many freight cars are in the train. You'll be able to try out this automation yourself on your own layout and modify it however you like. I'll include the script for the automations in a post on my community page, which I will link to in this video's description. The automations that we create today will use timers and won't require any additional hardware modifications to our layouts to use. In my next video, we'll create a version of the automation that uses a sensor to detect when our train has reached the end of the layout. After that, we'll look at a more complex automation that uses 2 locomotives working together to switch freight cars from one track to another. Be sure to check this video's description for links to the other videos in this series, along with links to my video series on assembling a DCC-EX command station and my series on using JMRI's Decoder Pro app to control our trains, as well as the various websites and products I mention here. Also, if you are enjoying the videos, please leave a comment and hit the like button. And if you haven't already, be sure to subscribe to the channel. It's always busy on the railroad around the holidays, and there's no time to waste. So grab that switch list and let's get started. Automating a train with DCC-EX EX-Rail. As I mentioned in video number 6A, meet the D-Saver 1-foot by 6-foot HO scale switching layout. Each time I finish an operating session on the D-Saver, I notch up the throttle on the locomotive, release the brakes, and sound the horn as the locomotive heads off the layout. After doing this manually several times, I decided to create an automation in EX-Rail to do it for me. EX-Rail is the automation component that is included within the DCC-EX EX-CommandStation software, and it is the easiest way to create automations for our layouts if we use DCC-EX. For this first example, we will look at the automation I use to drive the train off the layout each time I complete an operating session on the D-Saver. This is a very simple and straightforward automation that will provide us with a basic introduction to using EX-Rail, but will also allow us to look at some of the advanced techniques for controlling our automations that will serve us well in the future. Here's what's on the switch list today. First, we'll plan out our automation by thinking about what we want to accomplish and in what order. Then we'll dig into programming and testing our automation in EX-Rail and learn how to structure our EX-Rail scripts to keep them organized and easy to work on. After that, we'll look at how to trigger or run our automations using various types of throttles and controllers. And of course, we'll run some trains. Our locomotive is ready, so sound the horn, release the brakes, and roll on out. Automating a train with DCC-EX EX Rail. Part 1. Planning our automation. Now that we've learned a little bit about what EX Rail is and what it can do, it's time to start creating our own automations. The examples in this video build on the concepts we discussed in the last video, especially those related to EX Rail sequences and aliases. Be sure to do a quick review of part 2 of that video if you haven't already seen it or if you need a refresher. While I could simply show you the finished automations and explain what each part does, I think it would be more instructive if we went through the development process for the automations and came up with the scripts together. Thinking back on the example from my last video of making a cake, I could show you the finished cake and then tell you how I made it. But I think it would be better if we made the cake together, step by step. This won't turn any of us into a master chef, but at least we'll get a taste of how a baker works, and maybe that will inspire us to try it ourselves. We'll do the same thing with our automations. I will include the entire script for the automations from today's video in a post on my community page, which I will link to in this video's description. You can try this automation yourself on any section of track on your layout. Be sure to read the comments in the script for the items that you will need to customize to match your locomotive's DCC decoder programming. Before we can do anything else, however, we need to figure out what we want our automations to do, and then plan out how we are going to make that happen. For this example, we want to write a script for a simple automation that will drive the train off the layout at the end of an operating session on the D-Saver. The ingredients for our automation will be the locomotive and freight cars in the train from the operating session, and the track will be our oven. Here's a broad overview for what we want to happen. First, we want to drive the train to the end of the layout. Then we want to stop the locomotive before it hits the wall. After that, we want to back up the train to its starting point and shut down the locomotive. We can turn each of these steps into a separate sequence in our automation, with each sequence containing multiple instructions, such as sounding the horn or applying the brake. If we spend a little time planning our automation in advance, it will make writing the script to perform the automation much easier. We will go into more detail about what each of these steps entails in the next part of this video, but looking at this list, it should be clear that one of the most important things we need to figure out is how to make sure that the locomotive stops before it hits the wall. There are several different ways that we can do this, but for this video, we will do it by using a timer, just as if we were baking a cake. So we will use one timer while the train is driving down the track so that we can tell it to stop before it hits the wall. Then we will use another timer when the locomotive is backing up to its starting point before it shuts down. In my next video, we will look at how to do these things using sensors. One wrinkle that we need to throw into the mix is that the distance the locomotive needs to travel to the end of the layout is not always the same because the number of freight cars in our train is not always the same. As I described in my video number 6A, the outbound train for each operating session on the D-Saver includes one locomotive and from 1 to 4 freight cars, which are randomly chosen by the D-Saver switching puzzle app. The number of freight cars will change the amount of time it takes for the locomotive to get to the end of the layout because the starting point of the locomotive and the distance it needs to travel, as well as how fast it moves, will depend on how many freight cars are behind it. Unfortunately, as I mentioned in my last video, EX Rail does not allow us to pass this kind of information to our automations when we activate them from the throttle, which means that we can't tell the automation how many freight cars are in the train when it starts. To get around this limitation, we are going to need to create 4 slightly different versions of our automation with different length timers depending on whether there are 1, 2, 3, or 4 freight cars in the train. This is like a cake recipe that tells us to bake the cake for different lengths of time depending on what size pan we put it in. It is also similar to the example from my last video, where we looked at creating 3 slightly different versions of an automation to drive a train around the layout 1, 2, or 3 times. As with that example, we will use EX-Rail sequences to help us plan and create our automations. Again, EX-Rail sequences are groups of related commands and functions that perform a specific task. By using sequences, we can create 4 separate automations from nearly all the same script. For our example today, only the timer information needs to change depending on the number of freight cars. None of the rest of our script does. So by breaking up our automation into multiple sequences and separating out all the timer information, we can plan things so that we write most of our script just once. EX-Rail sequences are handy tools for helping us script our automations, but they are normally invisible to the user. In other words, they don't show up in a train throttle. Instead, we trigger or activate sequences from within our automation script. However, EX-Rail does offer 2 special types of sequences that do show up in train throttles: automations and routes. The difference between automations and routes is that when we trigger an automation from our throttle, EX-Rail automatically assigns the locomotive that is active in the throttle to the automation. Conversely, EX-Rail does not assign a locomotive to a route. We can still use routes to control locomotives, but the locomotive will not be assigned from the throttle. Otherwise, sequences, routes, and automations are all the same. Thinking back to our plan for driving the train off the layout, we are going to need 4 slightly different automations that will appear in our throttle so that we can select the right one to use when we send the active locomotive on its way with from 1 to 4 freight cars. We can then place the rest of our script in a series of invisible sequences, the same each time, triggered by the 4 automations. I call this set of automations Roll Out. Now that we have a plan, let's get started writing the script. Part 2. Scripting our automation in EX-Rail. Getting ready. Now that we generally know what we want our locomotive to do and have some basic idea for how we want to organize our work, let's write the script to make it happen. As I mentioned in my last video, scripting or programming in an EX-Rail is done using simple text commands in the myautomation.h sketch, which is part of the DCC-EX EX-CommandStation code. For today's example, we will edit this sketch using the Arduino IDE. So we'll start by opening the CommandStation-EX.ino sketch in the Arduino IDE as we have done in prior videos. Then we can use the 3 dots menu at the right-hand side of the tab bar to select the myautomation.h tab. Remember, the Arduino IDE sorts capital letters before lowercase letters, so this tab will be listed near the bottom of the menu. If you've been following along from my other videos, you may recall that we first created a simple automation using the myautomation.h sketch in video number 4D, Configure DCC-EX Wi-Fi for Station Mode, and then added our locomotive roster to the myautomation.h sketch in video number 5D, using Y-throttle and engine driver with JMRI and DCC-EX. However, if you haven't previously created a myautomation.h tab for DCC-EX, we can do that now in the 3 dots menu by choosing New Tab from the top of the list. We need to make sure we name this new tab to be exactly myautomation.h, all in lowercase letters except for the first A in automation. If we are creating a myautomation.h tab for the first time, we also need to type in 2 lines of code at the top of the sketch. The first line will say Auto Start, all in capital letters, and the next line will say Done, also in capital letters. Now, before we do anything else, we need to take some safety precautions. One of the things about automations in EX-Rail is that it is easier to start them than to stop them. This could cause problems if our automations don't work as we expect. So we will create an automation that stops all our other automations and sequences from running. This will be like having a fire extinguisher on hand in case our cake catches on fire in the oven. We will make this automation a root so that it shows up in our throttle. So in the myautomation.h sketch, under the lines that say Auto Start and Done, we will type root, all in capital letters, followed by an open parenthesis, then the number 911, followed by a comma, and then the words Stop Everything in quotes. This will create a new root, number 911, that will show up in our throttle with the name Stop Everything. On the next line, we will type Kill All, again, all in capital letters. This will stop the automations and sequences running in EX Rail. Finally, on the next line, we will type Done. We now have an automation in the form of a root that we can use in an emergency, or if something is not working properly with our other automations. Now we could continue to write all the script for the rest of our automations right here in the myautomation.h tab, but eventually we may have several different automations, and having them all here in one tab could get messy and confusing. Just as the different components of the DCC-EX software are written across many different sketches and tabs, we can do the same thing for our automations and put each automation or group of similar automations in its own tab if we like. This will help keep our work organized and more clear, and make it much easier to update and change in the future. So the next thing we will do in the myautomation.h sketch is type #include quotes myautomation_rollout.h end quotes. This will tell the Arduino IDE to include the sketch for our new rollout automation, which we haven't yet created, when the IDE compiles the DCC-EX CommandStation code. Now we will create the new sketch by using the three dots menu again and choosing New Tab from the top of the list. We need to make sure that the name for our new tab exactly matches what we typed in the #include statement with the same capital and lowercase letters. For this example, I named the new sketch myautomation_rollout.h with a capital A in automation, a capital R for roll, and a capital O for out. We can check to make sure that the names match by attempting to compile the code in the IDE by clicking on the small round button with the check mark in the upper left corner of the IDE window. If the code compiles without any errors, then the names match. If the IDE gives an error message that the file is not found, then the names don't match. We can either fix the name in the myautomation.h sketch or rename the new tab we just created by using the Rename command in the three dots menu. One word of caution about using the Rename command in the three dots menu. If we use that command to rename a tab after we have successfully included it in other parts of our sketch, the IDE will not update the #include statements in the rest of our code. Yet the IDE will still include the tab even though the names don't match. This can cause some serious confusion down the line when trying to figure out what the code is doing because the names won't match as expected. Okay, we are finally ready to start writing the script for the rollout automation in our new sketch tab. The rollout automation. Let's start by adding a comment at the top of the page to indicate what we are working on. Remember, we start all comments with 2 forward slashes. Next, we will create some of the aliases that we will use in our automations. Alias is an EX-Rail function that allows us to substitute one value for another anywhere in our script. In my last video, we discussed some of the advantages of using aliases in our automations and how aliases make it easier to understand what our automations are doing and modify them in the future. We'll start by creating aliases for our DCC decoder functions. Different types of DCC decoders have different locomotive function mappings. The locomotives that I run on the D-Saver are all equipped with Athearn Genesis OEM diesel versions of the Soundtrack's Tsunami 2 decoder. However, I have changed many of the locomotive function mappings to make them easier to use on a wireless number pad in JMRI. When you create your version of the script, you'll want to use the function mappings for your DCC decoders. It may sound like a lot of extra work to do this now, but it will save us a lot of time and hassle later, and will also make following what is happening in the script in this video much easier. Eventually, we will want to put most of our commonly used aliases, such as our locomotive function aliases, on their own myAutomationAliases.h tab in the Arduino IDE, so that all of our automations can refer to the same aliases. But for today, we'll just keep them here with our rollout automation script. So before we go on, we'll create our first sequence called setLocoFunctions to store all the aliases for our locomotive decoder function settings. Technically, EXRail identifies all sequences by number, like the number 911 that we gave to our Stop Everything route. However, we can also refer to sequences by name by, you guessed it, creating an alias. So the first thing we will type is alias, all in capital letters, followed by an open parenthesis, and then the name of the sequence we are about to create, set_locofunctions in this case, followed by a closed parenthesis. Note that we don't use quotation marks in EXRail when we declare an alias. Alias names can include letters and numbers, but not spaces or other characters, and are case sensitive. Also note that all EXRail commands, including the alias command, must be written in capital letters. Now we'll create the setLocoFunctions sequence. We'll type sequence in capital letters, open parenthesis, the alias we just created for it, set_locofunctions, and then close parenthesis. Again, there are no quotation marks. To end the sequence, we will use the return command. This will tell EXRail to go back and continue with the rest of the rollout automation once the setLocoFunctions sequence is done. Let's add some comments while we're at it to explain what we're up to. Now let's set aliases for a few of our locomotive decoder functions. For each decoder function we want to use, we'll type alias, all in capital letters, with the name of the decoder function and its function number in parentheses. We'll pick alias names that are easy to remember. We'll also add comments for each one. We'll start with the basics: headlight, bell, horn, and short horn, which are decoder functions 0, 1, 2, and 3. We also know that we are going to want the independent train brake function, which I have set to function 4 on my locomotives. Since our locomotives may not all have the same function mappings, there may be times when we need to create custom aliases for some of those locomotives. For example, suppose that we have a locomotive, number 123, that still has the independent train brake function set to the factory default of F11. We can create another alias called FN_brake_123 to represent locomotive 123's brake function number 11. We'll add more of these function aliases later on when we need them. Now we can finally get started on the main rollout automation. Eventually, we will need 4 slightly different versions of this automation, but we'll start with just the one for now. Again, we are using an automation sequence for this because we want it to appear in our throttle, and we want it to run using the active locomotive from our throttle. We'll type automation, all in capital letters, followed by an open parenthesis. We then need to assign our automation a unique ID number of our choosing, followed by a comma, and then a descriptive name, in quotes, that will be displayed in our throttle app. Note that we are not going to use an alias here because we want to assign the 4 slightly different automations specific sequential numbers, as we'll see later. For this example, we will give the automation the ID number of 11 and call it Roll Out with 1 car, because we are going to start with the automation we'll use when the locomotive is taking just 1 car off the layout. We then type a closed parenthesis to finish the line. We can add a comment after the end of our code to remind us what it is for. Now we can fill in what we want to happen in this automation sequence. We'll start by penciling in some comments, then come back and add the code for the script later. In this case, we want to drive the locomotive down the track, wait for the first timer, stop the locomotive before it hits the wall, back up the locomotive to its starting point, wait for the second timer, and then stop and shut down the locomotive. We then need to end the automation sequence by typing "Done" in capital letters. We now have a broad outline of what we want our automation to do. Now we can work on the individual steps we want each part of our automation to take. For these next steps, we will use the generic EX-Rail sequence command because we don't want to see these individual steps listed in our throttle apps. We'll work on these steps one at a time, just the way we planned them. Sequence 1. Drive the train to the end of the layout. The first step we want to work on is the sequence to start the locomotive and its train heading down the track. We'll use an alias to call this sequence drive_loco. We then create the sequence using the drive_loco alias in parentheses. Again, there are no quotation marks. We'll also add the return command to tell DCC-EX to go back and continue with the rest of the rollout automation once the drive_loco sequence is done. We also need to tell the rollout automation to run the drive_loco sequence. We use the EX-Rail call command to do this, with the alias for our sequence in parentheses. Again, there are no quotation marks. We can add this in front of the first comment we penciled in for the rollout automation. Now let's figure out what we want the drive_loco sequence to do. Let's start the action by displaying a message on our LCD that the locomotive is rolling out. We can do this with the EX-Rail LCD command. We'll type LCD followed by an open parenthesis, and then the line number from 0 to 7 that we want to display our message on, a comma, and then the message that we want to display in quotes, followed by a closed parenthesis. In this case, we'll let everyone know that our local is rolling out. We just need to remember not to make our message too long or it will be cut off on the display. Also, because the programming track and the main track on the D-Saver are connected to each other with insulated rail joiners, we want to issue a join command to join the programming and main tracks and avoid any short circuits when cars or the locomotive cross between the two. Now we can send the commands to get our locomotive ready to drive off the layout. We don't simply want the locomotive to start moving. That's not much fun. Instead, we want the locomotive to set the brake and notch up the throttle. After a short wait for the prime mover to spool up, the locomotive should release the brake, sound the horn, and drive towards the end of the layout. Since we don't want the locomotive to take off like a rocket when we release the brake, we also need to make sure that the locomotive's momentum setting is engaged, and that we haven't accidentally overridden it. We can pencil this in with comments in the sequence. Now, we'll tackle these in order. The first thing we want to do is set the brake. That means we are going to start using our locomotive decoder functions. So let's call the setLocoFunction sequence we created earlier now. Once we've called that sequence, we don't need to do it again anywhere else. Now we can set the independent brake by using the FON function with the FNBrake alias in parentheses. Just so we can see how it's done, let's also look at how to use the alternate function mapping for the hypothetical locomotive number 123 we created an alias for. To do that, we use the DCC-EX ifLoco command with an else and an end-if statement, so that if locomotive 123 is active, we use its custom alias. Otherwise, we use our default alias. Let's add a short 100 millisecond delay to make sure the brake is really set before we continue. To do this, we'll use the EX-Rail delay command and enter the number of milliseconds we want to wait in parentheses. Now I mentioned that we don't want the locomotive to take off like a rocket when we release the brake, so it's important that we make sure that the momentum is working. I've got the momentum settings on my locomotive set very high, but there is a half-speed override function that will turn the momentum off, which we don't want, so we need to make sure that the override function is not active when we release the brake. I have that function mapped to F10 on my locomotives. So before we continue, let's add an alias for the momentum override function to our setLocoFunctions sequence. We'll call it FN_momentum. We now want to make sure that the momentum override function is off, So back in our drive loco sequence, we'll use the foff function with the fn momentum alias in parentheses to make sure that the override function is off and the momentum is on. Again, we'll add a short 100 millisecond delay to make sure the locomotive receives our command. Now, let's set the throttle to forward speed 50, which is about 40% of full throttle. To do this, we'll use the forward command with the speed from 0 to 127 in parentheses. One thing to note about speed steps in EX-Rail is that speed 0 is stop and speed 1 is emergency stop, while speeds from 2 to 127 represent throttle speeds from 1 to 126. So to set the throttle to a specific speed step, we need to add 1 to the setting in EX-Rail. So we will type FWD parentheses 51 close parentheses to set the throttle to forward speed 50. Then we'll add a 5,000 millisecond or 5-second delay to give the prime mover some time to spool up. We're now ready to release the brake. We'll just use the foff command with our fn brake alias. As I said, I've got the momentum settings on my locomotive set pretty high, so let's also add a 1,000 millisecond or 1-second delay after we release the brake so the loco will start rolling. We are now ready to sound the horn. The Tsunami 2 has several options for the horn. We can use the standard non-latching horn, or we can use the latching short horn. For the rollout automation, however, I prefer to blow the grade crossing signal. Fortunately, the Tsunami 2 decoder includes a function for this. On my locomotives, I have that function mapped to F22. So before we continue, let's add an alias for the grade crossing signal to our set local functions sequence. Now we can activate the grade crossing function in our drive loco sequence with an fon command. And since we only want the grade crossing signal to sound one time, we need to turn it off with foff shortly after we turn it on. We also need to include a short delay between when we turn it on and when we turn it off. Otherwise, we will turn it off before it has a chance to sound. We'll use 500 milliseconds or half a second for that. We have now completed the drive loco sequence, which is the first part of our rollout automation. Let's add a 5-second delay in the rollout automation just after the call to the drive loco sequence to see how far the locomotive gets at this throttle setting, and then try it out to see how it works. First, let's check our code to make sure there are no errors by using the checkmark button in the upper left corner of the IDE window. It's not unusual to have errors when first compiling an automation script. The most common errors are caused by not using the correct capital and lowercase letters, misspellings, missing commas and parentheses, or alias names that don't match. We just need to review the code to correct any of these grammatical errors that we find. Then we'll upload our new automation to our DCC-EX command station by using the Upload button with the arrow just next to the checkmark button. We can then open the serial monitor in the Arduino IDE. We do this by clicking the icon in the top right of the IDE window that looks like a magnifying glass over a series of dots. Opening the serial monitor will cause the Arduino to reboot. Once the command station reboots, we can try out our new automation. To do this, we need to place a locomotive on the track. For this example, we'll use the same Southern Pacific GP40-2 number 7623 that we ran in our last operating session. Then, on the serial monitor command line, we will type an open angle bracket / start, all in capital letters, the DCC address of our locomotive, 7623 in this case, and the ID number for the rollout automation, 11 in this example, and then close angle bracket. Once we have it all typed in correctly, we'll hit return or enter. Now we can see what we've done. All right, so far so good. We saw the local rolling out message on our LCD display. the locomotive prime mover spooled up, the brake released, and the locomotive started rolling, while the grade crossing signal sounded on the horn. A few seconds later, our automation finished and the locomotive stopped. Note that when an EX rail automation completes, DCC-EX sends an emergency stop command to the locomotive. This sets the locomotive throttle back to 0 and results in a loud air brake crash on the Tsunami 2. We'll want to keep this in mind when we work on the script for the last part of our automation. Now I think we are ready to move on to the next part of the rollout automation. Sequence 2. Stop the locomotive before it hits the wall. Before we work on our next sequence, we need to determine how long we want our locomotive to drive down the track before we stop the locomotive. This will be a matter of trial and error, and we will eventually need to do this for a locomotive pulling 1 car, 2 cars, 3 cars, and 4 cars. For now, though, let's just focus on 1 car. We can easily edit the time the locomotive drives by changing the delay for our first timer in the rollout automation. We saw that the locomotive didn't get very far in just 5 seconds. So let's try 10 seconds. Again, we can upload our sketch to the Arduino and try it out on the command line in the serial monitor. If 10 seconds isn't enough, how about 15? We may decide to increase this even further later, but for now it looks good enough. We can start working on our next sequence to stop the locomotive before it hits the wall. First, let's create our new sequence. We'll call this sequence Stop Loco, so we'll create an alias with that name, then add the sequence command, some comments, and a return statement after. Then we'll call the Stop Loco sequence in the rollout automation. Let's pencil in the Stop Loco sequence now. First, let's update the message on the LCD display to indicate that the locomotive is stopping. Then we'll set the throttle to 0. EXRail offers a stop command to do that. We'll also add a 200 millisecond delay after the stop to make sure the locomotive gets the message. In most cases, that might be enough, but as I mentioned before, I run my locomotives with a lot of momentum, so just issuing the stop command won't actually stop the locomotive anytime soon. And certainly not before it tries to bore a tunnel through the wall. So to get the locomotive to stop, we also have to turn on the momentum override function, which turns off the momentum. Remember, we created an alias for this function earlier because we wanted to make sure that the override was off when we first started our locomotive. Now we want to turn the override on so that the momentum will be off. So we'll use the fON function with the fn momentum alias. This should cause the locomotive to stop right away. Now that the locomotive has stopped, let's get it ready to back up the train to its starting point. For this example, we will have the locomotive back up very slowly in silence. First, let's make sure that if we had the bell on, we turn it off. We'll add a short delay and then turn off the bell. Now let's quiet down the prime mover and silence the locomotive. I have the prime mover RPM settings mapped to F26 and F27 on my locomotives. To notch down the prime mover, we will use F26. First, let's add that alias to the setLoco function sequence. Then we can use the function in the stopLoco sequence. We'll add another delay, then fON to activate the function, and after another delay, fOff to unlatch the function. This will start shutting down the prime mover. Now we just need to wait for the locomotive to finish quieting down. 18 seconds seems about right. Then we mute the locomotive. I have that mapped to F8. So let's add that alias to the setLocoFunction sequence and then put it to use. Before we forget, let's turn off the momentum override so we can get the locomotive's momentum back. Again, we need a short delay first. Finally, let's wait one more second before we finish the stop loco sequence and return to the rollout automation. Let's try our work. As before, we'll upload our sketch and then enter open angle bracket /start 762311 close angle bracket in the serial monitor command line. That looks great. Our train moved on out down the track. The locomotive stopped before it hit the wall, and the prime mover shut down. Now let's back up the train to its starting point. Sequence 3. Back up the train to its starting point. This will be an easy one. Let's create a new sequence called Back Loco. As before, we need an alias, then the sequence, and return commands. Let's also make sure we call the sequence from the rollout automation in the appropriate spot. First, let's show a message on the LCD display that the train is backing up. Now, the only other thing we want to do is have the train back up slowly. We can use the EX-Rail reverse command for this. We'll try reverse speed 4, which will be speed step 3 on our throttle. That's all there is to it. We're done with this sequence. Let's go back to the rollout automation and enter a delay for the second timer. When we rolled out at speed step 50, we ran for 15 seconds. Let's start by backing up for 30 seconds. I'm sure that won't be enough, but better safe than sorry, and we can always add more later. Let's try it out. Upload the sketch and enter angle brackets /start 762311 angle brackets in the serial monitor command line. All right, that came back about half the distance. Let's try backing up for 60 seconds. That's pretty good. We're almost there. We can fine-tune it by adding a couple more seconds each time we test it out until it's just right. Okay, let's move on to our final sequence. Sequence 4. Shut down the locomotive. Our last sequence will shut down the locomotive. We'll call this sequence Shutdown. Back it up, buddy, gonna shut you down. No, not more singing. Oh, all right. Again, we'll start with an alias, name the sequence, add a return, and call it from the rollout automation. We'll display a message on the LCD that we're shutting down. Then we'll issue the stop command. Now we may not realize it because the locomotive has been muted the entire time we've been backing it up, but the prime mover is running again. So let's shut down the prime mover like we did before by latching and unlatching the FN RPM down function. As before, we want to make sure to add a short delay between function commands to make sure that the locomotive receives them. Now let's turn off the lights. This locomotive has a strobe light and ditch lights in addition to its headlights. These are on F5 and F6. Let's add those to the set local function sequence and then turn off all the lights. Hopefully you can see why we went to the trouble to name all our functions with aliases. If we ever change the function mappings on our locomotive or want to use our automation on a locomotive with different function mappings, we only need to update the set local function sequence and don't have to worry about changing anything else in our script. And while we haven't done it for this example, we could even create aliases for the two timers so we could have different length timers for different locomotives. But I'll leave you to try that out. Okay, what's left to do? Let's add a delay of 8 seconds to give the prime mover a chance to finish shutting down. Now we can turn off the mute function to unmute the locomotive. Now that we can hear the locomotive again, let's play some cab chatter. I have that mapped to F7, so we'll add that to the set local function sequence, then latch and unlatch the function. Then we'll wait 10 more seconds for that to finish. Finally, we'll unjoin the programming track from the main and display our regular message back on the LCD display. And that wraps up our first automation. Let's try it out. We're experts at this part by now.
CEY-CX, you'll be going in for Amtrak at Springdale, over.
For rollout automations. We now have an automation to roll out our locomotive in one car. But how do we roll out with 2 cars, or 3, or 4? Easy. We only have to copy the rollout automation sequence and adjust the delays. We don't have to change anything else. So we'll just select the lines of script for the rollout automation and copy and paste in a new set. We'll number this automation 12 and call it rollout with 2 cars. Now we just need to edit the delays. Again, this will be a matter of trial and error, but we can start by subtracting about 2 seconds for each additional car when rolling out and about 12 seconds for each additional car when backing up, and see how that works. We'll repeat this process to create automations 13 and 14 for 3 cars and 4 cars. Then we just start the locomotive on automation number 11, 12, 13, or 14, depending on whether there are 1, 2, 3, or 4 cars in the train. It's that simple. We now have the complete set of rollout automations we need to drive the train off the layout at the end of an operating session. That's great, but now we want to use them. So let's look at how we can run them from our throttles. Part 3. Running our automations. Now that we've created our first set of automations, let's look at how to use them. We'll start by looking at the Y-Throttle and Engine Driver apps. We'll also look at how to run our automations from the EX Web Throttle app in Google Chrome. After that, we'll check out how to run our automations in JMRI. Let's start with the Y-Throttle app. Note that we can only run automations from the full version of the Y-Throttle app, not the free light version. Once we have the Y-Throttle app open and connected to DCC-EX and our locomotive selected from the roster, we'll go to the throttle window. Then, in the throttle window, we'll swipe right on the function buttons to see the turnout and route control window. The window will open with the turnout control screen. However, if we click on the small icon in the upper right corner of the window that looks like a circle with 3 yellow dots in it, we will be taken to the route control screen. Here we will see all the automations we just created. These are shown with round icons with 2 red dots in them. We will also see the 911 Stop Everything route we created when we first started that we can use in case of trouble. To send our locomotive on its way, we simply select the automation we want to use. For the rollout automation, we'll select the one with the number of cars in our train. That's all there is to it. We will immediately see the throttle jump to the set speed. If we swipe back to the function button screen and watch, we will see our locomotive's various functions being activated by the automation. Note that we can still control our locomotive while the automation is running, but this could lead to some unexpected results depending on what the automation does. For the rollout automation, if we speed up or slow down our locomotive during the automation, it could end up driving off the layout. So we'll want to be sure to pay attention and be prepared to step in and stop the locomotive or cancel the automations if necessary. The Engine Driver app works very similarly to the Y-Throttle app. We connect to the DCC-EX command station, select our locomotive, and then swipe left on the throttle screen to see a list of our routes and automations. The automations each have a button that says Handoff, while the routes each have a button that says Set. To activate the automation or route, we simply click its button, and off the train goes. Again, if we swipe back to the throttle screen, we can see the throttle and the functions update as the train works its way through the automation. Now let's take a look at the EX Web Throttle app in Google Chrome. First, we need to make sure that the debug console is on. Then we can connect to our DCC-EX command station. If we look in the console window, we will see that the EX Web Throttle app polls the command station to get a list of all our automations and routes. Now, let's select our locomotive. Running an automation from the EX Web Throttle app is just like running it from the Arduino IDE serial monitor's command line, except we don't use the angle brackets. So, for example, to start our locomotive 7623 rolling out with 1 car, we would type /start 762311 on the debug console command line and press return or enter, or press the send button on the screen. For 2 cars, we would change the 11 to 12, for 3 cars to 13, and 4 cars to 14. Again, if we watch, we will see the throttle slider and function buttons responding as the automation puts the locomotive through its paces. Note that the EX Web Throttle app also has a separate screen where we can see our automations listed. To access this screen, we click on the small button in the upper left corner of the window with the icon that looks like a sideways S, and we will see all our automations and routes listed there. Unfortunately, during my testing, the handoff feature didn't work, but that might be addressed in a future update, so be sure to check back later. We can also trigger our automations in JMRI's Decoder Pro app in much the same way. In my videos number 5E, using physical controllers with JMRI and DCC-EX, and number 5F, managing JMRI locomotive rosters, We looked at some of the JMRI features specifically designed for DCC-EX, including the command line that we can use to send commands to DCC-EX using its native DCC-EX protocol. We use this command line to send commands to DCC-EX just as we did in the EX Web Throttle app. So again, to start our locomotive 7623 rolling out with one car, we would type /start 762311 on the command line and hit return or enter or press the send packet button. And if we open the DCC-EX traffic monitor window, we can see all the commands being sent to and received from DCC-EX. We also saw in video number 5E how to use physical controllers, including macro pads such as the Stream Deck controller with JMRI to control our trains. We can set up these devices to send DCC-EX commands using the command line, making it easier to trigger our EX rail automations with just a button. It is also possible to create control panels with buttons to activate our routes and automations in JMRI's Panel Pro app, but that is a topic for a future video. Part 4. Let's run some trains. We have now seen how to create a simple automation to drive a train with a locomotive and from 1 to 4 freight cars from one end of the track to the other and then back again using a modular and flexible approach with timers. We will extend this even further in the next video by adding the option to use a sensor. We can use the lessons we learned today to create even more complex and varied automations in the future. But the light is fading and we've done enough today, so let's go run some trains. What's next? Adding a sensor to our automation in DCC-EX EX Rail. In my next video, we'll create a version of the rollout automation that uses a sensor instead of timers to determine when to stop the locomotive. This will be very easy to do because it will use all the same sequences as the automations we created today. After that, we'll look at a more complex example of an automation that uses 2 locomotives working together to switch 3 freight cars from one track to another. To do this, we'll learn some new ways to control the flow of our automations so that they take turns working in tandem. And again, we'll do this without needing to add any additional hardware to our layout. The sun sets early at this time of year, but we've made all our drops, so let's head back to the yard before the light is gone. Until then, thanks for watching. Hey Scratchy, why didn't you come back with anything from your shopping trip? They threw you out for climbing the store Christmas tree. Scratchy. All aboard!